and switch. That's the easiest part of it. And again, the fact that I see some of you do this nice and easy, I feel really good about what's happening this unit. Because for most of us, logarithms, exponential form, we did not know how to do it before this. And other students actually get confused on the switching part. They'll write the 380 and put the 5 on it. Base, always base first, and then switch. All right, so here's what the long version looks like. The long version of this, which I guess I'll rewrite the whole thing in black, I'm not exactly sure why. Let me give some space. The long version says if the X is floating in the sky, to get that X down like a balloon, you have to tie something onto it. For this lesson, of course, we're going to tie a log onto it, and that way it'll come down to the ground. How do you do that? You just write log right in front of it. What you do to one side, you must do to the other. That's no big deal. Which is why standard 3, they have like about 5 problems for you to do. 4 of them are just kind of straightforward. And if you remember your moves, you're going to be good. The 5th one isn't a big word problem, so that one's a little bit more challenging. Say again?
Are you doing the longer version right now?
I'm doing the long version right now. But I will catch up to the short version as soon as I bring that guy down. I want to look X here. By definition, the log allows you to bring down the X. That's the whole point of the word log. It's the opposite of an exponent. In other words, if you have multiplication, the inverse is, division. If you have subtraction, the inverse is what? Addition. And if you have exponents, the inverse is is log or logarithm. In other words, this thing undoes that the other part. In any case, let's write that 5. There's a 5, and there's the log 380. Those who weren't here last time, any question about what just happened? The last move is X times something equals that. Well, when you multiply something times each other to solve it, you just divide that same thing on both sides. And now some can see the short version, which I'm gonna write the short version over there just for a second, so that again, not only can I look out for the people who were here last time and now you get to see both versions, but those who weren't here, at least you get to see it. And there's a division problem. What did we find out to be the actual answer?
3.69.
3.69?
That's what I go to.
Take a look at it. See if you want to ask anything. Say it again. Oh yeah, table on the other side by the window.
Whoa.
Yeah, I would have taken that because again, yeah. All right, so let me do the short version really fast. Dave and Marcos, take a look at the short version really fast. The short version goes from here to here. That part's exactly the same. So I'll write this out super fast. We do the base and switch. That part's no big deal. Assume all right. The short version is this. If ever you got the X in the ceiling and you need to get it down, you can always circle and draw down. That's the phrase that says circle and draw down. What does that mean? I have the X equals the 380
I wanted to go there early, but there was teaching
over the 5.
I'll open it anyway.
And then the only thing you have to do is, if you just punch this in as your division problem, you get the wrong answer. The thing you have to add is the log. In any of these exponential problems, the log is important. And then in your calculator, you just hit log 380, close the parenthesis, divided by log 5, close the parenthesis, the end. So this is the short version that you will learn to do after you've done the long version a bunch of times. But you got to know both versions, especially the long one. Free, standard, 3. All right, here it goes. What page is this one? This page?
That is 10.
All right, go to page 10 if you're not already there. Hey, Thomas, please graph this version. Standard 2, go ahead and put down standard 2. Hey, why is he having us put all standards on these things? When it's time for you studying, you will need to review before the test. You can go, okay, standard 3, 2, 1, okay, got it. Thomas, please graph without numbers. Let's say I don't have any numbers here and I want to graph this. There are two things that will always happen. If it is just a regular problem like this, just a base and an exponent, there's a certain place that's always going to go through. And that place, that y-intercept, anybody have it on the paper right now?
It is
0,
0, comma, 1. Now there's a way that this will change if I had something extra, which I'll do the extra version first. But the 0, comma, 1 will always be that because if x were a 0, automatically anything raised to the 0 power would equal 1. And the y-intercept is just what is y when x is 1. Sorry, what is y when x is 0? We'll do enough of these so that you will see that, okay, when x is 0, y is going to be 1. That's the first thing you need to know. The second thing you need to know is, hey, what does this picture look like? An exponential function. It always looks like an airplane taking off. And so this airplane in this problem starts right here. Even if I didn't put in any numbers in there, it takes off. It just has to fly through that point 0, comma 1.
Is it the J curve thing?
Uh-huh.
I studied in biology. It's weird.
Oh, okay. Yeah, it shows up in different places.
Yeah. I just learned it.
Once you know that this is what the picture looks like, then when we change the numbers to 5,000, it doesn't matter. It's an airplane taking off. What does it have to fly through? Whatever the y-intercept is. What will the y-intercept be? 0, comma 1 in most cases. So I'm going to start you off with the most cases situation. And then from there, we'll start adding extra things that will mess it up a little bit. But since you know what happens most of the time, you'll be right. Let me go to another problem. I'm going to have you sketch the picture. We'll come back to this one. I'm going to add a new problem and make it look different than that. So here we go. Where's that other problem? It has a front. What do I want you to do on this one? Please sketch the graph on this problem. The question will be like, okay, so will a fraction change it?
What is that?
It's a fraction.
Page 11, mine looks weird. I don't know what happened to them in there. Maybe the equal sign in there. Please sketch the picture that goes with this. My hint to you is two things. One, it's an exponential function, and they always look the same. Airplane is your hint. Two, second hint, the y-intercept is always the same. Please try and sketch that, then I'll do it. And you'll start seeing a pattern. I'm going to come around. Once you think you have it, raise your hand.
What did you do? Like, look at this photo like you see. Like,
Someone say out loud what the y-intercept is.
photo stuff.
0.
0, comma 1. Now on mine, I'm going to actually put it in the actual spot. Some of you, I looked at there, some of your airplanes started early. The reason you want your airplanes to start back is there are two questions they're going to ask once you have this. Because this part is so easy, and it's going to happen just about the same every time. They're going to ask a question about where did your airplane start, and where will your airplane end, which is called the end behavior, which I'm going to try and explain. Because again, easy, medium, and then I'll show you the work on it. Like, whoa. But it'll be the same thing. It'll be airplane taking off. You'll need to know what the y-intercept is. Then you need to know, does it go up high? And where does it start? So here comes, what do we have here? This one, we got this. All right. Any questions about this messed up?
Oh, I want to not be.
Don't draw the picture for page 12 yet. Do not draw the picture for page 12 yet. Y equals 10 times the 3 over 2. S. Here's what I want you to write down, please.
That was not that easy.
Go ahead and write down.
What happened is it's your board.
It's messing up, but I'm going to try and work with it anyway. Please write down the answer for 4 to the 0 power. what that equals.
I don't know. I'm pretty sure they didn't prime.
Please write that one down. We're going to do 3 in a row. 3 in a row.
Okay.
Pretty sure they.
All right. Out loud, what does 4 to the 0 power equal?
1.
All right, we got 1. No big deal. Let's do the next one. Next one. Let's do 3 to the 0 power.
That's 1.
Right. 8 to the 0 power is 1. Here comes the last question of this type.
Oh my God. Oh. 1.
3 over 2. Please write this one down. What does it equal?
1.
Yeah. Anything to the 0 power equals 1. So what is it that I'm trying to get you to do? And here it comes, the new version. Notice here, even though this problem appears messed up, notice here that this problem has this 10 in front. This 10 in front, the number that's in front of the thing raised to the power, it turns out that thing will always be the Y-intercept. Please write from that 10, Y-intercept.
Instead of call him.
Oh, Marcos. Boy.
All right. Go ahead and write down Y-intercept. Now here's what that means. Before, when there was no number in front of the fraction, we know, okay, it's going to equal 0. Or rather, if this was a 0, this whole thing would equal 1, and that's why it's going to be 0, 1.
Wait. Really?
But here's the deal. Because the 10 is in front, once we change this thing into a 0, or rather into a 1, let me see if I can erase this to show what I mean. If all of this equals 1 times that 10 that was in front,
It's 10.
automatically now the new Y-intercept, if there were a number in front of the base raised to power, it now automatically equals that thing.
Oh, I think it just equal 1.
Right. So what is it that he's trying to say to them? Before, if there's no number, the Y-intercept, where the airplane crashes through the Y-axis, is 0, 1. If there's a number in front, it's now 0, whatever that number is
0,
in front.
10.
Is there even 10 on this?
Now what I'm going to do for this, for your for sketching purposes, you don't have to find where 10 would be. You can just put a dot, like here I'm going to put a dot here, and I'm going to call it
I found 10.
0, 10.
It's the last problem.
Alright.
Wait, can you take that?
Well, I'm going to say it again. I'm going to do it again. But in short, and now draw your airplane through that new Y-intercept. Okay? So basically what we said as we're drawing our airplane here is, if you get an exponential function where it has an extra number in front,
See, that's a Y-intercept.
it turns out that that extra number is the Y-intercept.
Should my computer
What is
be
the
like
all-white one?
vibrating like this?
We turn this thing here, anything raised to the 0 power is 1.
Oh, so
10
it's times 1.
Wow.
Oh, so all you need to solve it, and then the Y-intercept is 10, and then it's always just going to be 1.
Always an airplane shooting through the air. The only part you have to figure out is where will it crash through the Y-axis. On that page, you can circle A and let yourself know that that's also the Y-intercept. On page 15, before we even draw a picture, I'm going to ask you to write down what you think the Y-intercept is. In this formula, do you guys already have this formula written down, or we never wrote it
No,
out?
we never do that.
Okay.
We're kind of just
All right. Well, then let me set that one up, and then have you choose a Y-intercept. So here's what you need to know to do on page 15. So go back to page 14.
Oh.
On page 14, here's some of the information you need to know, so that when we go to page 15, we can set it up, and then from there, we'll choose the Y-intercept. Page 14, this is the official formula for those long word problems. There are 4 pieces of the puzzle. The Y and the X, they always come with it. You don't have to do anything. The Y and the X, you just Y first, X at the end. The 2 pieces you need are the middle pieces. How do you find A? In the problem, they'll usually say, we started with 700 of this, or we started with $500, or it began at 101. Wherever it began, that is the initial amount. So right above that beginning, where did it begin? When you read a big word problem, that's going to be one thing you're looking for.
I'm not gonna do
The other part that you're looking for is this B. It is called sometimes the rate, the growth rate, and you can see down here, growth factor, the rate of change. You can underline those down below. But what this will say is something is going to double. That makes it a 2. Something's going to triple. It would make the letter B a 3. Or the famous one with money, so that you know what it is going to go by a percent. 15%, 2.5%. To find out what that B is, there's certain things you look for in a word problem. If ever you hear a percent, then automatically you're going to know, oh, that's going to be the B. Unfortunately, there's going to be a twist there, but at least right now, I look for 2 things. One, usually the first number is money. They gave me $340, and it changed, or it grew at 45% increase. Let's turn the page and see it in action. Those are the only 2 pieces you need. Let's see if you can find it. Is this the level of problem you will get on the test? Yes. They won't just give you the hook graph beginning with the 4 px. All right. Wish me luck. Here we go. Let's read this problem, see what they gave us.
I'm not ready.
Thank you. Since 2005, nothing about dates, remember that? The amount of money spent at a restaurant in the U.S. has increased by 7%. Go ahead and circle that 7% and put the letter B next to it. Write that down, Milo and Carlos. Let's keep reading. In 2005, about $360 billion was spent at restaurants. You can go ahead and circle that 360, and you can put A. Because again, there are only 2 letters. If you can find 1 letter, automatically you have the other one. The question is, what? Well, I'll say most of the time. Yeah. If it's the thing about money and percentages, the money will usually be the initial amount, and then the percentage will be the growth factor. So do me a favor, write down your money down here. Hopefully it doesn't feel too hard right now. And then for the growth factor, there's going to be a trick to it, but I'm going to start you off. Step 1, write the growth factor as a percent. Number 2, and you must always do this, you must change that percent into a decimal. If you forgot how to do that, you cross out. Let me do it below someone's watching the video. Can someone say what 7 as a decimal is going to be?
0.7?
Close on both of you.
7.07.
0.07, because you have to move it 2 times. So cross out 1, 2. That's old school. We're not teaching that for this lesson. So this is equal to 0.07. Here is the last thing that's going to mess you up on the test, but I'm telling you, so it doesn't have to. Once you write that as a decimal for the growth rate, when we write out this equation, you always have to add $1 to this 7 cents. In other words, you have to add a 1 to it. What does he mean? He means this 0.7 has to be written as a 1 plus the 0.07. Anybody know what $1 plus 7 cents, $1 plus 7 cents is?
$1 plus 7 cents.
Right. So it's going to look like this. Now, just like an exponential function that takes off like an airplane, flies through the Y-intercept, which is 0, 1, the first time you see this, you'll be like, okay, that's weird. The second time, you're like, okay, that's weird. The third time, you're like, okay. So basically, I'm going to turn to decimal and put a 1 in front of it. Let me write out the formula and let you stare at it for a moment so you can be like, okay, I see where everything came from. A, B, X. The A is 360. That's no big deal. The B, in this case, is this thing here. That weird number, 1.07, and it's raised to the X. Now, my goal here wasn't complete to teach you, okay, how do you build it? My goal here is, once you have it, they're going to ask you 2 questions. They're going to ask you, of course, to graph it, which we're going to graph in a second, so don't worry about that. But they're going to say, what is the y-intercept? Well, let me ask. Can anyone just looking at this say what the y-intercept is?
360.
It's a 360. How do you know where to find the y-intercept? It's the guy that's not connected to the exponent x. It's that guy in front. If there was no 360 here, what would the y-intercept be?
Okay.
And it's closed.
Why do we use a dollar? Why do we
It would be 1.
change 7% to 0.07 and then why do we put a dollar? I don't understand that part.
All right. That part those are just the steps. Step 1, when you find the growth rate, it's written as a percent, but you first have to write it as a decimal.
Well, why do you have to write it as a decimal?
Just as the steps of what to do. In other words, you don't get to just put this guy as a percent in here. Yeah, this is just one of the rules of the steps to do.
Why the dollar?
That's the second arbitrary step, which is when you're doing a growth rate, it always has to be 1 plus the percent. If it was a decrease, it would be 1 minus the decimal. Yeah, just do the step. Like, why they're making us do it? That part someone figured out. My goal is just to say, can I do step 1, step 2, step 3. Do me a favor, please sketch this. By doing your airplane, you know what the y-intercept is. Are you going to get 360 up here? No. So you just choose a spot where you want your 360 to go, and then draw your airplane. And then I'll do mine. You'll see if you're able. I told some people, there's nothing magical about my 4. It's just I want it lower up so it can pass through. 0, 360. Here comes my airplane. Let's see if we can get one last airplane, and then start answering the other 2 questions. First question I'm going to ask you, fortunately, is what is the y-intercept? Which is easy enough to be able to give them the y-intercept. So on this one, please write down y-intercept is, let's see if I can get this, y-intercept, which is why I had you, come on, y-intercept, colon, 0, 360. That was the reason I was having you write it on your picture, so that when they ask it from you, you're just plugging it off the picture, you're writing it down. The second question, the end behavior. Let's see if we can graph one. No. We're going to back up to the, we're going to back up to some of those other ones, describe the end behavior. I'm going to have you describe it here, then you'll put it all together in one ugly problem or 2, and we'll see how that thing goes. Here it comes.
Why is 0, 360? Why isn't it just 360?
It can be written in both versions. Normally you say, what is the y-intercept? It is true, they're asking you where does the green line hit the y-axis. So you can say, oh, it hits it right there at 360. So it could be one number. But usually they want you to write it in the coordinate form. That is this dot here, that is 360 on the y, is also written as 0, 360.
I get it, but like, why wouldn't we just write it if you only want one?
I want the y-intercept, but written in coordinate form. So I'm only doing it because they asked me to do it that way.
Were you always this smart?
Well, I'm going to go with, because I have to teach and say it over and over, anybody can be super good in 1 or 2 little things. So in other words,
Like in high school, were you this intelligent?
close enough. I was like you all. I had a memory. As long as you have a memory and you choose to memorize it, then you're good. If you have memory but you don't choose to memorize this, like history, oh, you're not very good in history. No, I just.
But you don't even hesitate when you say it. Like, so.
Well, I've been teaching. Yeah, I've taught it a zillion times, though. Okay, I'll take it. Thank you. Thank you. I'll take it. Say again. Please go back to 11 and 12. We need to start answering the final of the 3 questions that they will ask you with these. Hopefully I did it in such a way that nothing has been super confusing yet. And that's my goal. Make it not super confusing.
Are we doing 11 or 12 first?
What page is this one? Page 11. Go to page 11. Here comes the 3 questions I'll ask you. Please sketch. Boom, sketch is done. Please write down the y-intercept. And don't let Ashley make you have any issues with that. No. Please write down the y-intercept. I don't know where I'm going to put mine. I'll put it here.
You asked way too many questions. You talk to me.
And here comes the last part with a highlighter. Please highlight end behavior. Part of this is going to be simple. Part of it might be weird. So let's see if I can say the simple part first, so at least you get half. Here we go. On this picture, the end behavior simply says, when I look at my green arrow, one end of it is this part over here with the green arrow part. The other end is where the airplane began. Okay. On my picture, if I was demonstrating the end behavior, here's how I would do it. As this green arrow goes to the right, the arrow goes up in the air. Okay. That's baby talk for, okay, as green goes this way, it goes up, no big deal. We're going to write it in math form in a moment. I just want you to feel like, okay, I know what they're talking about. The other part, though, is as this green goes back that direction, and that direction has a name called negative infinity. This direction has a name, it's called positive infinity. This arrow, you would think it's going to go down to negative infinity, but it won't. As a matter of fact, every exponential function will never cross this line here unless they do something special, but most of the time, it won't cross it. Now, someone said in Brian's class in Algebra B, they did something like this, maybe a long time ago. Nonetheless, anybody know this line here? I'll say it this way. I'll write down the formula for this line, and I'll tell you where it comes from. The formula for this line, which is our x-axis, so it can be confusing, the formula for that line is actually y equals 0. This line is actually y equals 0.
Oh, yeah, we don't have math class.
Okay. Why is this line y equals 0 for those who weren't in that class? Well, we know here y is 2 on the y-axis. Here y is 1. Oops, I went too high, so let me erase that. Again, here 2, y is 3 right here, y is 2 right there, y is 1 right here. And if you go down one more line, how much is y? Yeah, 0 right here. Y is 0 right there. For that reason, if someone said, hey, please write out the equation for this line here, this x-axis, you would write out y equals 0. Now, why is that important? Because in order to answer these arrows on this side, one of these arrows is going to go point at the number 0. So let's do this side. Do this side. We'll do it a second time. And the third time, you'll do it. So there we go. This is the third question they're going to ask you. 1, sketch it. Boom, I got that. 2, what's my y-intercept? Boom, I got that. The third one, they said, please now describe the end behavior. Here's what you're going to write. We're going to put the answer down here in a moment. I'm just going to put it up here so it connects. As x, let me write it in blue. This first arrow just says as x goes to positive infinity, that is, as we go down the line that way, y, and I wish I would have put it side next door to it because they like to write it side by side. I'm gonna move it over so I can have space to write. As x goes to positive infinity, y is going to go up and up forever and ever, also to positive infinity. In regular talk, as we go this way, the green arrow goes up that way forever. That's regular talk. But for math talk, you have to write as x approaches positive infinity, x goes to negative infinity. Here is the other one that's going to confuse or trick some people. As x goes to negative infinity, that's left side here, this thing here, oh no, I need space, so let me give myself space. As x goes to negative infinity, this y is not going to go to negative infinity. You would think it's going to go down and down. No. This airplane is approaching this line. It will never touch this line. What's the line called that graph approaches but never touches? Asymptote. This asymptote happens to be 0. That is, as we go down, this green goes down, down, down. It will keep coming closer and closer, approaching that line, but it'll never touch it. How do we say that in math talk? We say that it's approaching 0. If this asymptote happened to be below that at -1, it would be approaching -1, but it's not. All right, we'll do it a second time on the problem right next door to it, the one with the 10. But pause. Anybody have any questions about this line here? Or this line here? And then it gets bumped right there. Well, let's see. We'll have you do the next one.
Wait, what are we
Write
writing
down
down?
right. Like, which one?
You are writing, if I'm writing it down here where the question is being asked, the end behavior will be written this way. As x, I will do this side first and this side second. As x goes to positive infinity, y goes up and up forever also to positive infinity. And then the second line is this side. As x goes in the opposite direction, we call that negative infinity. For this purpose, where the airplane is taking off, y goes to 0. That's the best we can do with the y's.
It's going to be like the same for everyone.
Yeah, unless somehow the picture gets moved around, but most of the time, the y, or the green line, is going to take off from the x-axis, and therefore, right to 0. Do me a favor, please write down the, I'll leave this up for a second, please write down the Y-intercept for page, if this is page 11, page 12, that's page 12 right next to it. Yeah. On page 12, please write down the Y-intercept and the end behavior. Now again, I am starting you off on the baby ones. We need to get to one that has the big ugly numbers. Page 12, what is the Y-intercept, please? 0, 10. The end behavior. Uh-huh.
Y approaches infinity.
Uh-huh.
Then x approaches negative infinity.
Uh-huh.
And then y approaches 0.
Take a look at it, take a look at it. Now we're going to go back to that big ugly word problem that had a 360 in it. And now you're going to go there, and you're going to do the same thing now. It's a big word problem, but I just want you to feel like if we can get the equation, then usually we're going to be okay. The other thing that we're going to do after we write it down on, is that page 14, that last one? The big ugly word problem? Page 15, go to page 15. Once we get to page 15, I want you to write in the same information, and this is going to be the first one that we're actually going to double check on decimals. We're going to double check this one on decimals. And we're going to type in one other problem on decimals that may be slightly different than this one. All right, I'm going to. I think I'm going to turn it on. It comes automatically. Page 15. Write down your end behavior, and then punch it into decimals so that. After you do one more of these, we're going to type in a very strange problem on decimals and look at what it looks like, and that'll be it. So we're going to do one more of these. Then after you do one more of these, we'll type a very strange looking problem and still try and answer the question. Hey, what's the Y-intercept, the end behaviors? You got to be ahead of the class on the one we're about to type in. So what are they doing? They're typing this one in. I'm writing the end behaviors that they're used to now.
I typed it in and it came out like a behavior.
All right. So you should have the x going to infinity, the y going to infinity also.
It goes like straight up after a while.
Yeah. X going to negative infinity. I'm going to come and take a look at your pictures on the computer just to make sure you're able to raise things to the power. Going to 0. Now, what is the B on page 16?
Is it 11 or 20?
Good question. The answer is, this is 16?
Mm-hmm.
We know it starts with that 11, where is it? So I can start, there it is, 11.5. Put your B right next to it if you highlighted it. Can I just switch it to decimal at the beginning? Let's see if that messes with somebody. I'm going to put the point 11, 115.
Is that in decimal?
Yeah, that is To turn it to decimal form, you cross out 1, 2. So if anyone forgot, okay, well, what if a decimal's already there? You still have to move it 2 places to the left to get rid of that percent sign. And then we do the 1 thing. Let me see if I can have them see that. 1 plus. This is why I'm saving. We don't have that many of these problems available to us. So that's why I'm going to save the last one for next class, because by next class you will have forgotten a lot of this possibly. So the actual B factor, the thing that we're going to put in the parentheses, is going to be 1 point. And some of you are going to start feeling the rhythm. That is, when I get this in decimal form, and I'm going to add a 1 to it, all that winds up doing is putting the 1 in front of the decimal. So if I had 0.15, that would be, 1.15. If I had 0.07, that would be 1.07. So whenever you change this by adding that 1, which you have to do, it just puts the 1 in front of it. What is the A? If someone had to guess what the A is in here, and it's not one of the 1,000 numbers.
It's 101.
Yeah, it's the 101. The problem that you probably get on your test, they won't have a bunch of numbers around, so it's going to be a little bit obvious. As a matter of fact, put a star on page 15. Page 15 is a lot like what you're going to see on your test, so that on this one, money.
Why is 101
8%. In this case, it says the atmospheric pressure at sea level. Sea level is kind of where things begin. Is about 101 kilopascals. For every 1,000 meters increase, they're just describing some stuff. Eventually, I want to know what happens at 3,000. But here, the 101 is where it begins. Good news for you, the test problem, they're going to do the money version.
Okay.
And the money version is a lot easier to tell who's that. Yeah. All right. Do me a favor, write the equation and sketch it. Once you write the equation and sketch it, write down what the what the Y-intercept is at the bottom, and what the end behavior is. In other words, you're doing a problem that would be appropriate for standard 2. Oh, I didn't actually do that. Write somewhere standard 2. Why? So that when you look at this problem, you know, okay, I'm working on standard 2. Standard 2, so you're going to page 72, you're putting standard 2. And again, hopefully all of you are after you can see, I try to say as much stuff so that when you do look at it again, it's there. So here we go. If you were going to put this one into decimals, please circle this equation right here. My next class, I'm going to read through all these words that even when I read it, like, whoa, I have no idea what you're talking about. But now for you, I study hard so that I can say the easy version to you so that you can take math less. Here's the deal. If you need to put this into decimals, find out what it would do. Try punching these letters into decimals to see if it accepts any of them. I expect that it shouldn't. We'll change them in a moment. If you look on your thing, if we were reading it, the H plus represents hydrogen atom. That's one thing. The pH is one thing. What is it you want you to know? As written, you cannot type it in and get an answer. But here's the other part you do know. Normally, what's on the left side of the equal sign is the Y. And what's on the right-hand side in this thing here is normally an X. So here's what I want you to write. And we'll see what the picture looks like on this. Y equals negative log X. Type that into your, write it, and then type that into your decimals. And let's see what the picture looks like.
Oh.
It's a full.
Go back straight up.
All right, yeah.
Just put it down.
And then it's so small.
Oh, never mind.
Zoom in on it. Look at this thing. All right, yeah, type it in. I see it on some. Type it in. So here's the two things I want you to do. I'm going to write down the end behavior, and we'll and then that'll be it. We'll talk about it some more. Hopefully we get to see one more of these somewhere. But let's look in. Intercept. Underline intercept really fast. On your decimals, here's what's true. That airplane, just so you can get a feel for it, it turns out the airplane has turned upwards. In other words, it's a rocket that's coming down now, and when it crisscrosses, it actually crisscrosses the x-axis, so it turns out it won't have a y-axis. Here's your airplane, it crosses here. Someone on the computer, please click. Is it 1, 0? I'm nervous about that. I thought the numbers were different. Mark where it crosses the x-axis. I need someone else to confirm that there are at least 2 people who have the 1, 0.
Yeah.
You probably have to zoom in some, because it must cross the 1, 0. So here's the deal. This particular problem won't have a y. Imagine this. You know how we normally our airplane takes off this way? They've kind of turned it where now the airplane is taking off towards the ground. And as a result, so in this case, here is the x-intercept. It won't have a y-intercept, which is why they don't say y. We'll talk about it when we do one more of these, not today, but the next time. The end behavior is the part I'm trying to get you to. Here's the part I'm trying to get you to. Please draw these arrows, and we're at the end.
What?
So Carlos made
Draw those arrows.
Just writing.
Milo, trying to get that part in, and still say what you're saying, but just trying to get that last part in. These arrows, just while it's still in your brain, because by Monday you will have forgotten the whole thing, so I just want to put in your brain. Here's what this means. As the x goes to infinity, goes to the right, you can see the y goes to negative infinity. It's going down, down, down. Can someone tell me, as x approaches, normally you would say as x goes to negative infinity, but guess what? X can't pass this line. X is stuck at 0. This one is weird, which is why I want you to at least see it. As x is trying to back up and get stuck on this wall, but y is going to, The thing I want here is for students who can see the picture, and those pictures on the decimals isn't that they're not that great. You can see the picture on here, what's happening, and be able to at least draw your arrows. So I'm gonna write the answer down here, then I'm gonna see if I can have you put your names in class. So I'm gonna pass this out today because I gotta teach this to the other class, and I need to hear from you. What was the muddiest part?
So your other class paper.
X goes to infinity, and as x goes to 0. Now on your test, there's going to be one similar to this, but you don't have to get all the pieces of it to get the points you need for that section.